Hello and welcome to STEM Pursuits with Mr. Clausen. Today we are going to look at the second day of lesson 5.4 where we're going to look at factoring quadratic expressions, and more specifically we're going to look at situations where the a term of a quadratic equation is not equal to 1. Plus we're going to look at some situations where there are special formats for quadratic equations that when you see them, like difference of squares or perfect square trinomials, that if you have these tools in your back pocket, it makes it a lot easier to solve some of these quadratics. So these are specific situations that we're going to look at today. So we're going to get started here. Since I've shown you some of the simple stuff as far as how to factor out a quadratic equation, I'm going to go through those a little bit more quickly. If you need to refer to that, please go to the first video of this lesson. But the first thing that we're going to do is that we're going to look at the a, the b, and the c term for this quadratic expression. So as a is equal to 2, b is equal to negative 19, and c is equal to 24. And what I'm going to do, instead of looking at my factors of 24, I have to look at the factors of a times 24. Again, we're unfoiling it, but because we have this 2 term here, a is not equal to 1, we have to take some other things into consideration. So we need to look at the product of a times c. And the product of a times c is going to specifically be 2 times 24. And in this situation, this is going to equal 48. And what I'm going to do is, now that I know that the product of my a times c term is 48, I'm going to look at 48 here, and I'm going to look at factors of 48. And specifically what I'm going to do is I'm going to only look for situations where the factors of 48 equal a negative number. And I'm doing this because I see that my b term has a negative value. So for example, we could go like negative 1 and 48. We can go negative 2 and negative 24. And we can go negative 3 and negative 16. And I'm going to stop right here because I look at when I have negative 3, and 16, that this has a sum of negative 19, which equals my b value over here. So once I find this and I see that the b value matches these factors of negative 3 and negative 16, I'm going to just get started and I'm going to use these. But instead of just going and plopping it into 2 binomials like I did when the a value equaled 1, I have to do something a little different here. And specifically what I'm going to do is I'm actually going to split, sorry, I keep touching that, weird. I'm going to split this into 2 separate portions. And I'm just going to go negative 16x minus 3x. And as you can see, the sum of these still equals the b term, but I'm splitting it based on these factors that I have over here. And the reason for this, I think, is going to become evident pretty quickly. But we'll plug the 24 here, and we'll plug the 2x squared here. And literally what I'm doing is I'm going to go and I'm going to look at these, and after I write these, I'm going to split it in half. And specifically why I put the 16 here is 16 has a common factor of 2 with the x value, and 3 has a common factor with 24. So that's why I put them where I did. More specifically, we can split this and I can say, for example, I want to find the greatest common factor between 2x squared minus 16x. And I see that 2x could be pulled out of each one of these. So I'm going to say 2x, and what's left from 2x squared is x. And in this case, I'm going to pull out a common factor of 2x, and I would have to multiply 2x by negative 8 to get negative 16x. And the reason I'm going to do this is I see I have the common factor of 2x, and then what allows me to do is say 2x times x minus 8 is this half of my split apart quadratic is equal to 2x times x minus 8 in parentheses. And I'm going to do the same thing over here. I have negative 3x plus 24, and I see that negative 3 is a common factor of both of these terms. And again, I'm going to go negative 3 times x. In here, I'm going to go -3. But because I have positive 24 here, I'm going to multiply -3 by -8 to get this positive 24. Because if I multiply two negative numbers together, it's going to give me a positive number. And I did this very intentionally did this so that this -8 would match this -8 over here. And this is a very easy thing to correct if you don't do this right away. But what you're going to see here is that -3 is my common factor, and I'm going to have -3, and then x minus 8 is what's left. So we can factor out x minus 8. And the goal that I'm trying to achieve here is, now that I've simplified both halves of this quadratic that I rewrote here, what I've done is I actually have two binomials, one in each expression, part of the expression here, and they're exactly the same. So what I can do with this is that, hey, if I have this, I can actually factor this out and say x minus 8, and I can multiply this by the portions that are left, which is 2x and -3, and I can factor those out. So as I'm going through this, I very intentionally picked a lot of these terms as I'm going through, and what you'll find is, as long as you split this apart and you're going through it, really the only way you can switch things around by accident is that if we would have said 3 here instead of -3, you would have had like -x plus 8, and that's a pretty simple situation to see. So if you ever do that and you're like, oh, my x and the 8 and the x and the 8 are there, but the signs aren't right, just pull out a negative out, like I did here with the -3, and you should get what you're looking for. But if you can find these common binomials and you can factor them out, you can then rewrite this new equation. And again, if you wanted to check with your original expression, you can go x times 2x. This would give you 2x squared. That's important because that's the a term we have up there. We can go outsides, -3 times x, which would give you -3x. -8 times 2x, which would give you -16x. As you guys are probably noticing, this is matching the factors that we had here. And then we go -8 times -3, which gets our positive 24. So if we go and we check that to our original quadratic, you'll see that this matches up and that this term here is our solution. So our solution is 8 minus x times 2x minus 3. And that is how you would factor out a quadratic where a does not equal 1. So moving on, another thing that I want to show you is how to factor difference of squares. Specifically, this is looking at a situation where you might notice that there is a squared minus b squared scenario. And what I would encourage you to do is I would actually encourage you to write this down on your note card for a quiz or an exam. So really what I'm looking for you to know is how to apply this when you see this situation. So for example, if there is a x squared minus 64 situation, this is a difference, so there's subtraction involved. And what I notice is that both of these are perfect squares. So if we go x times x, that's a perfect square. If we go 8 times 8, this is a perfect square. And if you see this, the equation for this is always a squared minus b squared, and you have a plus b and a minus b as the situation that arises. So whenever you have a difference of squares, this formula will always hold true. So what I want to just say to you is that if you see these perfect squares show up, if you see any situation where there's like a perfect square at the front and a perfect square at the back of any quadratic equation, red flags should be flying up everywhere and it should be raining down sparkles like the 4th of July. Like, this is awesome when you see this, because we can just say, hey, a is equal to x and b is equal to 8. And all we would need to do is actually plug this into this format. So we can simply just say x plus 8 times x minus 8. These are also referred to as conjugates, but what's really cool about conjugates is that you can multiply these out. So if you FOIL it, go x squared, and then let's do outsides, which would be negative 8x, and insides positive 8x, and with the last, that's negative 64. The thing that's always true about conjugates is the middles always cancel out, and you'll always get your original difference of squares back, so it works. So your solution will always fit into this format, giving you this equation as the answer. And then you almost don't even need to do any work to show anything. If you identify that's the difference of squares and you have this formula on your note card, then you just go and you plug it into that format and you would be done. Another situation is perfect square trinomials. So this is a situation where you can go and you're trying to fit into a format again. And in this specific one, this is a pretty easy situation. If you identify, like, again, hey, perfect square, hey, perfect square, you can solve this pretty quickly using the method that we talked about in the previous video. But what I want to show you here is that if you see an equation and you see these perfect squares, there's actually this perfect trinomial situation that fits into the format I'm writing here now. A squared plus 2ab plus b squared. And this is equal to a plus b squared, indicating by its name, perfect square trinomial. It's two binomials that are squared, all right? So, and then you have a squared minus 2ab is also a situation that can occur plus b squared. And this is equal to a minus b squared. And again, this is note card worthy material. All right, put this on your note card. Sometimes you'll see in your textbooks, and I'll write it this way, I'll write it as a squared plus or minus 2ab plus b squared is, b squared is equal to a plus or minus b squared. Okay, so this is a situation that you can use as well for a note card if you want to save a little bit of space. All right, so with this in mind, if you have perfect squares on the outside, so if you have, you say a is equal to x and b is equal to 7, you might ask, well, how do I know if something's a perfect trinomial? Well, you have to do one little check, and you have to see if what you have to see is that the middle term is equal to 2ab. So if we pick an a value, we pick a b value, all you have to do is plug it in to what you have here. So you go 2 times x times 7. And specifically, we're going to look at negative 2ab. And if you get negative 14x, which we do in this case, it matches up with what we have right here, then that confirms that it's a perfect trinomial. If you get something else, then it's not a perfect trinomial and you have to use a different method to crack this quadratic. But if you see that this is a perfect trinomial, we're using the negative variation. So specifically, we're going to use this one. And we're going to just plug in and say x. All right, so what we're going to use is this negative variation here. And then we can just plug this in and we can go x minus 7 squared. And that is your answer. You are done. This thing is totally slayed. All right. So that was actually a pretty simple example. So what I want to show you here is I want to show you an application problem. I want to show you where the rubber meets the road and where this stuff totally saves you. Okay. And in this situation, you see that the a value is really gross. All right. But the thing you would see with this situation is 81 is a perfect square. And if we go 9x times 9x, that factors out. And again, if you see that the end result is also a perfect square, and that this is 2 and 2, all right, saving grace just came down. All right, this thing is actually solvable. And this is going to fit into the a squared plus 2ab plus b squared format, which is equal to a plus b squared. And again, you can't just go and plug it in and say, we're done. But what I would encourage you to do in this situation is like, hey, let's check it. I really encourage you to check it. But all you need to do is we're just going to check this 2ab and see if it fits this quadratic. we're going to go 2 times 9x times 2. And if we see that 2 times 9x is 18x times 2, and we see that equals 36x, and look, voila, this equals this. That means that this specific quadratic is a perfect trinomial, and that we can simply plug it into this format where a is equal to 9x and b is equal to 2. So all we need to say is 9x plus 2 squared is our solution. And this would be the answer, and you would be done. Okay? So again, key thing to look for is look for these perfect squares at the end. And if you see you have some perfect squares, then look at these equations, put them on your note card, and see if you can crack the code and then factor it accordingly into this format. So with that said, I hope this video was helpful, and I look forward to seeing you in class.